Hi, my name is Dr. Peter Loka, and it's a pleasure to be with you today. My presentation is titled Infrastructure, Governance, and AI, the Underside of the Online Learning Iceberg. And the iceberg is a great metaphor for online learning and AI use in that there's a lot of IT infrastructure beneath the surface that is complex that empowers the visual, cool stuff that you see above. And so this is the topic of this presentation, where first I'll talk about the cloud computing IT infrastructure that enables AI access throughout school districts, especially in Western Canada, but this is also applicable globally. So AI is a transformative technology. It's been in the public sphere of awareness for the past few years now, and people are using it extensively. The hope that I have for today's presentation is to fill in the understanding of how this is possible and what are the design considerations when educational institutions especially are building facilities or staffing to enable their next generation AI applications. So generative AI is effectively cloud computing. Cloud computing is access to someone else's computer, is a sort of short, sweet version of that idea. But what it means is that you're using the internet to access resources on a device other than the one in front of you, or more commonly, outside the school or institution or university that you're in. Now, this access to a third-party computer that is far more powerful, that is also analogous to the generative AI use, where you have very powerful computers with huge processing capabilities and a large body of data that they've been trained on, providing answers over the internet to the end user. So generative AI and cloud computing really follow the same journey. So I'm going to talk about the Western Canadian experience and what is going on in Western Canada in terms of IT infrastructure, and then the last part is going to be on the governance implications for AI. So this research is based on a massive study of 1.14 million students, 2.2 million plus square kilometers, and 100% participation rate from the eligible schools. Now, the eligible school districts, rather. Eligible school districts were defined as 5,000 students or more, where they were large enough to have a decision to either have a data center of their own or to use public cloud or a cloud of some sort. And the conclusion from this is that Canada is the land of the cloud, and that's what I'll talk about going forward. The last part of this presentation is, now that cloud computing is so common, what are the AI implications for this? And that's really the topic of today. So again, generative AI is cloud computing. And yes, there are a few exceptions where there are processors and small instances of non-cloud computing generative AI and large language models, but because they are so restricted in terms of their power, their capability, and the information that they're processing, those are such a minority. For the purposes of the presentation, generative AI is going to refer to large language models like Copilot, like ChatGPT, like Gemini. So just some background of who I am and what informs this presentation. So I'm the Director of Educational Technology at an independent school, a private school, a very prestigious private school in Western Canada. And I've been part of the digital transformation journey in education for the past 20 plus years. And so the idea was to take high stakes testing, high stakes education, and transform it digitally for the improvement of students. So this is one of the last final exams that was done at my old school, and then this was pivoted over to a bring your own device online exam environment. And in the time that I was at the school, the community went from a novelty of a few computers in a classroom to computers all available all the time. Students would bring their own devices, and even if the students weren't affluent, we found a way of supporting them. So what is cloud computing? There's a number of models from the NIST framework: private cloud, community cloud, public cloud, hybrid cloud. I don't have time to run through these, unfortunately, but basically cloud computing requires power, data, and hardware. And to do impressive things that generative AI can do so well, you need massive facilities. And this is going to be, I believe, the Microsoft or Google data center. And this is one of many around the world. So you can see the scale of these operations. And you're looking at a location that is secure, cooling is abundant, geopolitically stable, and these are huge facilities. Now, in the Western Canadian context, that is the foundation for this research. So Canada is a large country. And so this research was for British Columbia, Alberta, and Saskatchewan. And to give you a context, sort of, this is the size of North America. So the United Kingdom won't fit in a portion of one of the provinces, one of the 3 provinces that were part of the study. So this is a huge study, and it provides a snapshot of IT infrastructure in Western Canada. Now, even though it's a Western Canadian context, you're going to notice that there is an applicable lesson here across the world. So you have a beautiful city, a lot of people, gorgeous, but it's expensive. And so yes, you have IT talent, and they live in this dense city. Now, on the other hand, you have places that have a lot of real estate, a lot of space, but unfortunately, they don't have people. And so you need IT talent to manage your computers. And if you have those people, they're probably in an urban center where it's very dense and it's very expensive to have those servers and that capacity. Conversely, you have places where you have very few people and land is relatively cheap. So, and of course, in Canada, it snows. So one of the challenges that schools addressed with cloud computing was how do you get IT expertise and technicians to travel to schools when there's snow on the roads and the conditions are not great. So in the Canadian context, there's a massive geography and it's expensive to live in Western Canada. The school districts have central leadership, which again lends itself to the centralized leadership rather than separate schools. Broadband was available. This is a typical connection for a residential instance. And during the pandemic, of course, residential instance really allowed students to use the internet to complete their work, and cloud was effectively deployed rather than limiting students to in-school access. So the research, 100% participation rate, data transformation model, mixed methods, triangulation design was the methodology. To give you a sense of the granularity, hypergranular, this is the framework used. It was organizational adoption. Again, I'm brushing through this because I want to talk about the findings. And the findings are that Canada is the land of the cloud. So here you have cloud use, and you have the traditional on-premises, non-cloud use. In parallel, it's a minority. You'll notice that the bars don't always add to 100% because they were used in parallel at times. And so, again, the research that this is based on, hugely detailed, talks about the platforms and where they're run. Now, implications for future use. Cloud computing infrastructure, this represents the intention to use or discontinue use. Basically, once you go to cloud, you don't go back. Now, implications. Canada's a land of the cloud, always accessible, makes for easy access anywhere, and technology changes can be quickly implemented. So challenges for IT leaders. The reason cloud is so prevalent was because IT staff are expensive, and if you have centralized cloud computing, it's much cheaper than it is to hire people. Recommendations: don't run your own infrastructure. And now the classroom implications. If you have classrooms, they need to be maintained down that snowy road. So by moving things to a cloud facility, to a classroom that requires only Wi-Fi and students bring their own devices that rely on the cloud rather than in-school on-premises access, that's a far greater improvement in terms of both reliability and access at home. And so this is an example of just a white wall with a projector and a secondary TV, which is $1,000, and not a room full of computers, which are many, many thousands of dollars. So this is also more accessible. Another view of that same room. So this is a prototype for classrooms that we have at the schools that are working. Now, generative AI equals computing. So ethics, governance, and policies. So with generative AI, you should start with the principles. What are you okay with? And then develop some policies and then find tools. Now, the challenge is that you don't want students misrepresenting their work, misrepresenting AI as work that they have done themselves. And so we don't want to shortcut the learning. Now, one of the best approaches, I think, is for adults, teachers to model effective AI use. So when you are working with a class, you want to make sure that you're using AI to help you do the job that you're being paid to do. And so you're okay starting a lesson using AI and accessing that through cloud infrastructure, and then using that as a starting point to refine the work you're doing. It's not okay to just simply play an AI podcast to a class and then sit back and read a newspaper or read blogs or whatever one would do. So the trick is to really model effective AI use. Now, one of the challenges is that this is how this digital transformation journey started with pen and paper exams. One of the approaches that's being used now in Western Canada is when students have been using computers to learn, the final assessment might still be pen and paper because there really is no effective way to 100% block AI use. So there's some emerging technologies and approaches that try to do it, but there's nothing 100%. And so a lot of times the teachers that I work with and the schools that I work with, they'll do a final assessment with pen and paper, or they'll do a verbal examination with the student prior to reading their final product on the essay. So if a student used AI extensively in the essay and it's really not their work, the odds of them passing that verbal check aren't great. Same with pen and paper. If all the foundational work was done using AI and the student themselves, they don't really know the material that well, then that will be a problem that will be revealed during an in-person test. So there's a full circle that is happening here. And my hope is that with AI being so prolific that it becomes the norm, sort of like spell check has become the norm, and people still value the need to have the mastery of it. It doesn't become a crutch that displaces learning, which is another issue that's emerging in the IT leadership circles that I'm in. So the other concerns are reputation and data security. So data security is the idea that you're taking confidential student records and putting that into a public tool, and that information is no longer secure, private, or confidential. That's one of the primary concerns that used to be at the top. Now that, for me, that's been displaced by reputational risk, where an organization may use AI inappropriately and use it as a crutch, where the customer, the community member feels that they got shortchanged because the staff that are being paid to do the work didn't really do the work. They kind of outsourced it and did things through the least amount of effort. An example would be writing a retirement address or a birthday card to your grandmother, or wedding vows, or other things that are hugely personal. And this is where report card comments are sometimes tricky. So those are the things that we're wrestling. We want to make sure that we use AI to its fullest, but we don't want to harm the relationship we have with our students, customers, community members. Now, for the full research that this was based on, you have access through these links. My name is Dr. Peter Loka, and it's been a pleasure to spend time with you today. Thank you.